So I think we are good to go ahead. Guys, from today onwards, Hamsa will be taking UDS and CAN communication. So I think she will be starting with the CAN, then later she will be entering into the UDS protocol. So actually, she is having very good experience in the testing background with the CAN and UDS. So she will be explaining about all the use cases in the real time, how we will be using them, what is the need of all those things. Okay. So I think Hamza, you can go ahead. I think I have started the recording also. For each and every session, we are just recording the sessions. So you can go ahead.
Okay. Yeah, thank you, Lokesh. So, yeah, let me just introduce myself. As you said, my name is Hamsa. I do have around 4.4 years of working experience in automotive testing domain. I have worked with L&T and then HCL, and now I am working at Continental. So, yeah. So I think you all are already aware of already aware of what is the discussion it's going to be happen along with me. So it's CAN and UDS. So let's start with the CAN today. Okay, so let me share my screen. So before entering into the CAN protocol, I would like to, interact. I would like this session to be interactive. So it's not one to, only one communication. I would like to interact with everyone. So then only it will be understandable and it's easy for me to complete it. So clear? So if you are unable to respond, unmute and respond, you can also use the chat window. You can also send, or if you have any questions and you cannot unmute yourself, you can post your questions on the chat window and you can react or raise your hand. So for all the questions, whatever I ask for. Clear?
Yeah, clear.
Okay. Okay, then let's start. Okay, so before starting, I would like to understand how much you guys are aware of CAN. So first of all, anybody knows about the CAN? What is CAN? At least the full form.
Control area network.
Okay, so what does it means? Anybody knows?
It has two-wire system, CAN high and CAN low. It can operate only 0 and 1s.
Okay. So what is exactly CAN protocol means? Why exactly we are using CAN protocol? So first of all, let me ask the basic question. What is protocol and what is communication? Here we are talking about.
I think protocol is communication means sending the message to one area to another area or one node to another one. Protocols means set of rules and regulations, guidelines which you have to follow.
Very good. Okay, so you guys are already aware the basic. So what is the protocol meaning and what is communication meaning? So the communication protocol which we are talking about is CAN, and what is exactly the communication which we are discussing? It's between the one electronic devices to the another electronic devices. Okay, so now assume you have you guys would have seen already. So whenever you enter in the office, the lights will automatically turn off and automatically turn on. Whenever automatically turn on whenever someone is present, when the object is present, and it automatically turn off when the object is not present. Similarly, you would have seen in the many malls and everywhere, when if you place your, in the washrooms, if you place your hand, the water will, in the sink, water will come. If you take your hand away, the water will be automatically stops. So what does means exactly? How it is, what is used over there to perform these actions? Any idea?
Sensors.
Very good. So sensor is, what is a sensor job? It just, sense it and sends the inputs to the ECU. So the action will be taken by the controller unit. So how exactly it is sending the data to the ECU or the controller unit, sensor controller unit? So of course I'm just talking to you and you are able to understand because we are using a media which is a Skype. So how exactly a sensor can send the information to a controller unit by use like what is the mediator, or how when the brake is not working properly, or if you have not released your handbrake in your car, how come you get the notification in your dashboard that your handbrake is not released, please release your handbrake before start the car? How exactly that communication is happening? How exactly your dashboard can get that information from the handbrake that it's
There are
not released?
there are several ways is there. There is a one sensor is there, and in the instrument panel there is a one light, what we call it as. So it is showing or giving the alarm to awake a driver or passenger.
Okay, so wire is right, nothing but it's that is called a communication protocol. Okay, so why exactly we are using this type of communication protocol? So anyway, we are just starting the basics, which is a CAN protocol. Similarly, we do have multiple other communication protocols. The use of communication protocol is to establish the communication between the one ECU to another ECU. It's a mediator. Okay, so it's like same how we are using the Skype to do the communication between you and me. Similarly, this CAN protocol or any other protocol, it's just a communication protocol. All the communication protocols are used for the communication between the one electronic device to another electronic device. That is called a communication protocol. Is it clear?
Yeah, clear.
Okay. So now, anybody knows like I know other than CAN protocol, what are the other protocols are available in the market?
Lin mesh.
Uh, okay, I'm unable to hear. There is a lot of noise. Reddy, Hemant, can you please go on mute? Yes, please go ahead now. So, what are the other protocols available in the market?
I2C,
Okay, then,
SPI,
then,
UART,
then.
RS-432.
Okay, very good. Then,
Lin.
very good. Then, USB is also one of the communication protocol, right?
Right.
Then, what else?
Wi-Fi.
Sorry.
No. Wi-Fi. Wi-Fi.
Okay, Wi-Fi is
Not about.
yeah, because we are not electronic devices. I mean, of course, mobile is electronic devices. Yeah, Ethernet I would say,
Bl-
not the Wi-Fi, because Wi-Fi is
Bluetooth.
just a name which we have provided, but Ethernet is the what they have used.
Bluetooth.
Yeah. I mean, these are all end user names which are saying Wi-Fi and Bluetooth, but inside there will be a communication protocol like Ethernet, which they use. Okay, okay, fine. So almost you guys are aware of the protocols, but why are we discussing only CAN then? Why not all, or why not more other than CAN? Any idea why are we discussing only CAN, not others? Like we have discussed UART, I2C, SPI, FlexRay is one of the communication protocol, Ethernet, most. There are many more in the market. Why are we discussing only the CAN protocol? Yes, please, Anil. Go ahead.
CAN protocol is used in automotive.
Mm-hmm. Why not
It's
others then?
it is the heart of the automotive.
No, automotive is just an industry. Okay, so just now you got to know what is that communication protocol, means and why it is exactly used. It is not about the field. It's about the devices.
I think it is very economical and efficient.
Okay.
I thought
Then how about others, other protocols? It's not efficient and it's not economical, is it?
It is a multi-master, I think. So that's why there is no need of the master to control everything.
Mm-hmm. Okay. How about FlexRay and Ethernet? Like when you say master, then opposite is what? That's what I'm expecting.
Slave and master.
Okay, very good. Then then okay. So the first of all, to understand why exactly we have CAN protocol, we just have to, go for the history. So let's go for the history, how it was before using any of the protocols inside the car. Okay. So first of all, as we know, in the modern time, so how many ECUs would be using in the modern car? Any idea? Just consider autonomous car, just consider Tesla. How many ECUs would be using in that car to operate itself? So everybody knows what is autonomous car, right? There are levels L1 to L5. So assume L5 autonomous car. So it is gonna start by itself. It is gonna take you to the destination by itself. It is gonna apply the brake whenever it is required. It is gonna checking everything around you completely around the car, and it is taking you to the taking you safely into the destination. So how exactly that is happening? How is that even possible? Using electronic control units. So what is electronic control units means?
Microcontroller and
Mm-hmm. Microcontroller and then?
microprocessors.
Very good.
Sensors, I don't know, maybe.
Okay. Okay, so electronic control unit is one of the unit which will be having required hardwares on that. It's typically not, fixed. It's keep on changing based on the system to system. So when I say system is also called ECU. So what is ECU and a system? If someone is doing you a job, or if someone is taking, not someone, when I say someone, I'm talking about the ECU. So if some electronic devices is taking a action, nothing but, for example, if the ECU is applying brake by itself, that is one of the action which is actually doing by this ECU. That is also called a system. So whenever I say ECU or system or node, everything means same. Nothing but there is a electronic device which is taking an action. That overall is called a system or a node or an ECU. Clear? Okay. So come back to the last question. So when we are seeing the autonomous car. So how exactly it is operating? It is completely the operations which is have been taken care inside the car, including your wipers, your smart, I can say power windows, power doors, your gears. There will be no gears at all in the autonomous cars. I mean, there will be only, I mean, automatically it applies. If you want to take the control of the car, there will be only two gates. It's automatically applied by itself. So how exactly that is happening? By using the electronic control units. So how many electronic control units do you think it's required in a one complete L5 autonomous car to drive itself?
Around 380, 400.
Okay. So there is no particular or constant number of ECUs. We need more than hundreds of ECUs in a particular autonomous car to operate. Okay, so now let's say you have 200 ECUs in one car, and we already know that 200 ECUs, like assume 100 ECUs has to communicate. Nothing but if you are just entering into the car, if you press the key, it has to open the door for you, and you will enter, and you will provide your location, and it has to lock the door by itself, and it has to start the car by itself, and it has to drive by itself. If someone comes in between, it has to stop by itself. Correct, right? So every action taken by the ECUs. So now the ECUs has to communicate. Nothing but there should be a radar and cameras to detect the object around the car, and that camera and radar provides the input to the ECU, and that ECU will one of the ECU provides the input to the brake ECU, where brake ECU apply the brake. This is nothing but the three communication which is happening here. The camera and the nothing but it could be a sensor, it could be radar or camera, any of the one input who is detecting the object, and it provides the data to the sensor, where the sensor has the ECU, where ECU is taking an action whether it has to apply the brake or completely 100% brake, or it has to slow down the car. So this communication is happening by using the communication protocol, which is we are already aware. Okay, now we are talking about CAN. So now assume if the 200 ECUs wants to communicate, then how exactly it is going to communicate with the 200 ECUs? So someone said me that it is having a wire. So assume there are 200 ECUs in the car. This is how it used to be in the history. You have 200 ECUs and you are connecting by wire. So how it will be? Okay. So see in the dashboard, or you can take it as a brake ECU. So you are trying to connect every ECU and trying to display something on the dashboard. That time you have to connect with the hundreds of ECUs inside the car. If you are using a wire, how you have to connect it? Okay, one ECU to the another ECU, from this ECU to the it's clumsy completely, right? How you cannot connect through the wire. It's completely clumsy if you are trying to connect hundreds of ECUs in the car. Yes or no?
Yes.
Yes.
Then what's the
Yes.
best idea do you think to connect the every
Uh,
ECU?
Without wires, like using any Bluetooth or any other protocol.
It's not about the yeah, you said it right, without using the wires, because it is clumsy and we cannot connect hundreds of ECUs with the wires, because you will be confused and even the ECUs will be confused where to send and what to send. Correct, right? So because of that reason only communication protocols has come to picture. Okay, so where we have the CAN protocol with the bus technology. So what is bus technology? We are using a one of the bus where it is a one of the bus where we can connect multiple ECUs. It's a bus network like this. You can assume. Let me just open the paint. Give me a minute. Okay. Okay, so we will see in depth of bus now. Now, just understand the bus name. So this is a bus where we can connect multiple ECUs in one of the bus. So where it can, multiple ECUs can communicate each other without, like without any clumsy. Like before, how we have seen the wires, too many wires.
Hello. Hello.
Sorry, I
Your
was on
voice is
mute. Sorry.
yes.
I don't know how it became mute. Sorry. Where you guys have till heard?
The bus.
Bus. Okay. The bus meaning itself is a two wires. Okay. So by using the two wires, we are connecting multiple ECUs. where you do not using the multiple wires to connect the multiple ECUs. You are using only 2 wires to connect the multiple ECUs. So what is happening now? It's in a arrange, correct, right? You can connect, I mean, it depends on the what I can say, the quality of this bus, the wire. So that much is not required as of now. So just understand the bus is also, it's nothing but a 2 wire. You are having a 2 wire and you are connecting every ECU onto that particular 2 wires. So now what's is the improvement have you seen like in the history compared to the current use of communication protocol? What do you see with this to this?
It is easy to handle things, like
Okay.
not clumsy,
Okay.
not clumsy.
Yes. Okay. So by using the communication protocol, we are connecting multiple ECUs into the 2 wires. It's also called a bus. Okay. Whenever I say bus, it is having it's just nothing but a 2 wires. One wire name is called CAN high, another name is called CAN low. Okay. In the CAN communication protocol. So now, so this is the solution where technician has come up to identify the usage of multiple wires and to produce the efficient communication between the ECUs to ECUs. So we are going to discuss in depth how exactly ECUs communication is happening. But now the concept is to identify why exactly CAN protocol or communication protocol came into picture. Okay, clear now? What is communication protocol? And why exactly the communication protocol came into picture? Hello?
Yes.
Yes, sir.
Yes. Okay. So next question is why exactly only CAN? Why not all other protocols? It's nothing like we are not going to discuss like all other protocol or none of the automotive field is not going to use any other protocols other than CAN. So it's not like that. So including the CAN protocol, CAN FD protocol, LIN protocol, and yeah, someone said SPI, I2C, every protocol is used. But the mainly they are like for the efficient communication purpose, they use CAN protocol, and CAN FD protocol is a improvement of CAN. Okay, so the main reasons are it is a reliable, nothing but error-free communication. You will understand what is error-free communication in the later session. You don't have to worry. There is a specific session for the error-free communication. And then someone said it's economy. Yes, it is right because it is a low because cost because it is having only 2 wires, and hardware cost is also less. And then scalability, when it comes to the scalability, so here, as you can understand, it's a 2 wire. Based on the capacity of the wires also, we are able to connect the nodes. If you want to connect the less nodes, nothing but, as I said, when I say nodes, ECUs and system, everything is same. So if we are able, if I want to connect only less nodes by using the CAN protocol, I can do it. If I want to use only CAN protocol for the multiple nodes, I can do it. That is what is the scalability. And availability is available in the market, like and gain the name that it is a very good communication protocol for the communication purpose, and it's nothing but popularity. This is the reason we go for the CAN protocol and CAN FD protocol. Okay, so when it comes to the master and master slave communication, it's a master communication where it does not require someone else instruction to take the action. So as someone already said, master slave communication, when it can anyone explain what is master and slave communication now?
Master and slave means if any event is triggered, the master will detect and it will give the slave to operator. In master, it is no need to that what we call it as
Mhm.
it can operated by the master also only. Slaves can do the slaves can perform.
Okay. So let me just open this. Okay, so assume you are in a car now and you want to, reduce uh, take your window down. So what you do? You will press a button or a remote, right? Just to make your power window come down. Yes or no?
Yes.
Yes. So how it is taking you, like, whenever you press the button, so what is exactly happening, that who is get to knowing that you are pressing a button and it has to come down? There it will be used a LIN protocol. It is requires your input where you are giving the input and it will be considered, and LIN protocol will be, it's requires a input from the master. Here you are the master which is who has provided the request, and there will be a LIN protocol used in that type of power windows and power doors, because it is a even though if it is not working, it is not going to affect your life, correct, right? So it is used in the less critical functionality, not in the high critical functionality. And we will come back to why exactly and what is less critical and more critical and why exactly LIN, everything we will come back later. But this is the thing in the slave. So it requires an input from the master to take the action. Is it clear? That is what is called a master and slave communication. And LIN is one of the best example of master and slave communication protocol, which are always used for the less criticality. Clear?
Clear.
Okay. So moving on, we will come back to the features one by one. Once after I explain one of the feature, I'll come back to here and show. But just now I have finished one of this one. So CAN is a multi-master. It's one of the feature of CAN where it is a multi-master hierarchy. So what does it mean? The CAN is not required anyone's input. So can anyone give me the best example where exactly it would have been used in the car?
Auto braking system.
Very good. Then?
Handbrake.
Okay. Then?
Auto navigation.
Sorry?
Navigation.
Navigation. Okay. It's not much critical, but yeah. Okay. Then? I mean,
Wipers.
navigation is not right because you are the one who is going to provide the input. It is not taking by him, like, itself, that where you have to go, it is not going to decide it.
Okay, okay.
Okay, so engine, brake systems, airbag systems. So all these are very critical functionality when it comes to the car. Okay, so I mean, in that critical functions, we are gonna use CAN protocol. Because of its one use its master and master. Remember this, I will be asking when I go for the next advantage of CAN. You have to remember why exactly we are using CAN. The first feature is multi-master feature. Is it clear? I need answer, please.
Yes, ma'am. Yes, yes.
Okay. So next, let me move on to the next feature. So whoever uses Airtel network and Geo network, just say yes, Airtel and Geo. That's it. If anyone using
Yes.
Airtel and Geo network both.
Yes, me.
Okay. So what is the difference do you feel in the Airtel and Geo when you are especially using the internet?
Airtel is little bit slower compared to
Uh-huh.
Geo because Geo has only 4G spectrum, wavelength spectrum is there. But
Uh-huh.
compared to Airtel, Airtel have a three spectrums is there, 2G, 3G, 4G also.
Okay,
Coming onwards,
enough. Okay, so next question is when you say that low speed and the Geo is having a high speed. So what is the maximum speed which you have identified in Airtel and maximum speed which you have identified in Geo?
If it is
per second.
5G, oh, okay.
Like, if you see in your mobile, there will be something like 160 kilobits per second, 200 kilobits per second, 100 kilobits per second. That's the range, how your internet is working per second, how much data is transferring. Nothing but when you ask something, hey Google, how am I? It will say within how much second or within how much millisecond, how many millisecond.
It will take in the Airtel. It will take 1 or 2 seconds, and Geo fraction of seconds means milliseconds. Yeah.
Okay, very good. See, that is called that we have been just discussing the speed. That is called a data speed here. DLC data. Okay, so when you are using the CAN protocol, so what exactly we have seen CAN protocol? It's just same as a communication protocol. So when you are using your mobile, they have been using some, if someone is there, electronic student, they will understand which protocol they have used in the internet, or to get the 4Gs or 3Gs or 2Gs, whatever. Okay, so when it comes to the ECU to ECU communication, as we know, we are using the CAN protocol. As of now, we are studying the CAN protocol. So what is important here? When you are communicating between the one ECU to another ECU, what is important?
I think fast
Speed.
up
Yeah,
speed
very good. Yes,
better.
that is what is very much important, right? Because if someone is giving the transferring the data in very less time, as you said, Airtel is providing you the data in a low speed, what you do, you will go for Jio because
It is
it's
very fast.
yes. So let's just say in the car, if you are applying the brake and it is not applying the brake at that time, it is applying the brake after 3 seconds, what will you do? What will happen?
Accident will happen.
Yeah. So what we have to do for that? Nothing but ECU is applying the brake. When it has to apply the brake when it is required, not after some time or not before that, because it leads to a critical situation. So for that, what is required? A reliable communication. Correct, right? And the fast communication between the ECUs and ECUs. Okay, that is what is here. The main one of the feature is the CAN protocol provides the transfer rate, nothing but a data transfer rate up to 1 megabits per second. Clear? Is it clear?
Yes, clear.
Okay. So if you remember, we were just talking about the LIN protocol, which was a master and slave communication. The speed of LIN is very less, which is 125 kilobits per second, or in practical, it is still more less. So the CAN protocol speed is we can use up to 1 megabits per second. So now tell me, which one do you prefer? Because we are the end
CAN
users
protocol.
for all the protocols, right? So the client has to do the best for us. He's gonna select the same CAN protocol. So on the critical basis, correct, right? That's where the speed comes into the picture. CAN protocol will be used on the critical functionalities. LIN protocol will be used on the non-critical functionalities. So what are examples for non-critical functionalities?
Power windows.
Yes, power windows, power doors, wipers. Here the LIN protocols will be used. This is one of the feature. Okay. So like moving on to the next feature. Okay, I'll come back to the next feature when we discuss more about the CAN protocol. Can you guys please, I mean, whoever don't have anything to say, please go on mute. I think it's Mohammed. Okay. Okay, guys, any doubts still here? So you guys have understood what is communication protocol meaning. So first of all, what is communication meaning in terms of the electronic devices, and what is communication protocol? And then what we discussed, why exactly can we are still discussing, and how it was in the history, and how why exactly communication protocol came into picture. Okay, so any doubts, guys? I see only 2 members have been interacting. I want, others to confirm that it is clear till now because this is the basic.
Yeah, one doubt. Sure.
Yes, please.
Yeah, in Lean also it is it same the communication happen between issues like in the CAN
Yes, yes.
in Lean?
Like the protocol, communication protocol, whatever we are using, everything is between the devices to devices,
Yes.
electronic devices to devices.
Okay, so is it also like a two wire or a
It's
different
also two wire.
architecture?
Okay, so we are not getting in depth of Lin today. So our concentration is CAN. Okay, so if you need, I can explain you once after we complete the CAN. I mean, in depth of Lin.
Yeah, okay.
Sure, madam.
Okay, so any doubt so far? Okay, I'm considering that as no. So moving on. Okay, we'll come to this. So let's start the architecture. So we know that bus is, what is bus? What it is?
It is a two-wire system.
Yes. One wire name is,
Can high, can
another
high,
wire name is.
Can low.
can
Okay.
low.
So what I am connecting here?
ECU.
ECU or node.
Okay. So someone said that when I say ECU, what exactly it contains? So mainly, please go on mute once you have answered, please. It's disturbing. Okay, thank you so much. So when we say it's a ECU or a node, so what exactly it contains? So it contains CAN transceiver. It contains what? CAN transceiver. Anybody
Can
heard of
trans-
CAN transceiver name? CAN. I'm just writing down again here. Transceiver. Anybody heard of CAN transceiver name?
No.
Okay. I'll come back to that anyway. You can write it down. CAN transceiver. Another one is CAN controller. Another one is microcontroller. When you say an ECU or a node which is connected to the CAN bus, it hardwares. One is CAN transceiver, another one is CAN controller, another one is microcontroller. So why exactly we are using all this? Okay, so first of all, what does wires gives? Like just it's just a generic. So if everywhere wires are used, what exactly wire can give or take?
Data,
No, it's not called data.
data
I'm just
info.
asking normal,
trans-
like
they're
think as a
transferring the power,
very good. So what does it that power means?
voltage and current, a
Very
combination of.
good. Very good. So here, what exactly transmit? Voltage. So now we know this CAN bus is a voltage. That means, sorry, wire. Wire can, voltage will be flowing on the wire. So how exactly it is converting it as a data? So what is the language which can be understandable by the microcontroller or any other electronic devices?
It can understand only zeros and one, means binary form.
Very good. So now tell me how exactly voltage is converting into binaries.
Through converter.
Transceiver.
Very good. The transceiver job is to convert the voltage into binaries. Okay. So now how exactly it is changing? How exactly, the CAN transceiver is identifying how much is the voltage on the wire? And first of all, how the voltage is flowing on these wires? Nothing but a CAN bus. What is the input? Okay. So now, of course, as we already know, it's a communication between the one ECU to another ECU, right? To make this work, we have to connect the We have to supply the voltage. That's how it will be active. Okay. So now one ECU is started sending one of the data into the bus. Okay. Let's say assume it is just sending something. Now you don't have to understand what is 143 or 142, whatever I write. We will come back to that. So now try to understand the concept, how exactly it is converting. So let's say with the 143 identifier, it's sending some of the data with the 8 bytes of data. It is sending one like x1, x2, x3, x4 and x5 and x6. So whenever this frame has been entered the bus, so first of all, what can bus can understand, because it is a wire, nothing else. It can understand only the voltage. Okay. So now whenever it's sending the data from the one ECU, microcontroller can output only the binaries, zeros and ones. Okay. CAN controller, it's same binaries because it is a controller. And then comes to the CAN transceiver. So the CAN transceiver is job is to convert the voltage into the binary and binary to voltage. Correct, right? So how exactly it is converting? I have provided one of the example now. 140 with the 143 identifier. It's take with the DL3 8 bytes of data. It is transferring as of now. Just take an example. It is the CAN transceiver will convert that into voltage. So how exactly it is converting that to voltage? Okay, so first it will take the first byte. So whatever is happening, like see 143, I have it over here, which is an XOR value. So this XOR value, okay, before that I need to confirm. 0 means dominant, 1 means recessive. The name you just have to remember as of now. 0 means dominant, 1 means recessive. And you guys are already know what is 0 and 1, which is a binary format, which can be understandable by the machines. Okay. Okay. So now, as we know, the CAN wires can hold or voltage only will be flowing on the wire. So there should be a limit, right, for the wires. CAN high and CAN low. There should be a limit on the wires. How much is the voltage? Similarly, here also for CAN high, we have a limited voltage, and for CAN low, we have a limited, like limit of voltage, how much low it can go when it comes to the CAN low. And when it comes to the CAN high, what is the limit? Nothing but a maximum voltage it can support. Okay. Can anyone aware of what is CAN high can support the maximum voltage, and CAN low can go minimum voltage?
CAN high is 5
Right
voltage.
now it's 12 volts.
CAN high is 5. Okay. Then
I think a little bit doubt about no, CAN low. It will be 2.5, I think so.
okay.
It's
So
like
both is wrong. That 5 voltage it comes to when it goes to the microcontroller. Okay, there will be a power regulator which regulates it. It's that is not for the CAN bus. That 5 voltage what you have aware, that is different. That's not for the CAN bus wires. Okay, for CAN high it's 3.5 voltage, and CAN low it's 1.5 voltage. Okay, so how it is converting into the dominant or recessive? Nothing but a 0 and 1 by taking the difference between these two voltage. When I say difference, nothing but 3.5 minus 1.5. What is the output when you do the subtraction?
2 volts.
it's 2
Yes.
volts.
Whenever it is greater than 1 voltage, it is considered as dominant. Whenever it is less than that, it is considered as recessive. That's how it converts into the binary when it is in a voltage format. Or if the output is from the CAN transceiver, if it is on the binary, if like binary, nothing but if it is a dominant, it will be converted into the voltage, nothing but less than 1 sorry, dominant, right? If it will be converted into a voltage greater than 1.0, then it is considered as a dominant. Whenever it is recessive, it will be like it will be converting into the voltage less. That is the job which will be done by the CAN transceiver. That's why we do have the CAN transceiver. Okay, I mean it does many more, but this is the basic use of the CAN transceiver. This is the primary, the as the name suggests, it is a transceiver. It does the transmitting, and it is also receives the data. Getting the
Madam, I have
point?
one doubt.
Yes, please.
If it is comes to dominate, means the difference between the high and low volt, can high and can low, should be less than or
Less
greater
than one
than
voltage. Okay, let me write it down.
voltage.
What is the CAN high minimum maximum voltage?
3 volts, 3.5,
What's the minimum CAN low voltage?
1.5.
Okay, it's again, like as per the it depends on the like quality of wires and all. It depends, but yeah, in general. So if the one ECU is sending the data with the ID, let's assume 10. So when you take the 10, 1 means 0. If it is a 4 bits of data, 0 0 0 1, and 0 means 0 0 0 0. So now what is this? 0. So to get the 0, how, like, just okay, I'm coming reverse, so I'll come from here, so it will be easy for you. So assume CAN high as the 3.5 voltage and CAN low has the 1.5 voltage. What is the difference between these two?
2 volts.
Yeah. So whenever it is 2 voltage, CAN transceiver will consider this as a 0, nothing but a
0.
dominant.
Right.
Okay. Let's say even CAN high as 1.5 voltage and CAN low has, okay, let's do the reverse. CAN high has 3.5 voltage and CAN low has 3.5 voltage. What's the difference?
0.
Okay. So difference is 0. So now CAN transceiver convert into what? In terms
1.
of binary, it's a recessive. It will
1.
convert into 1. So now assume you have 2.5 and CAN low is, okay, sorry, CAN high is 3.5, CAN low is 2.5.
Yes, if it
So what's
comes
the
to difference
difference?
between 1,
Voltage is
1
1.
volts, 1
So
volt.
when that, yeah, so when it is a 1 voltage, what it will convert? Whenever it is greater than 1, it will convert that as a dominant. Whenever it is equal to or less than 1, again, it's typically depend on the configuration, which how they want to make. But this is the general. Whenever it is less than 1 or equal to 1 voltage, so it will be converting that voltage into recessive. So
Resist.
now clear
Right.
what is the use of CAN transceiver and how exactly wire is convert, like when the wire transmit the voltage, how exactly it is converting into data.
Clear, ma'am. Thank you.
Okay, great. Thank you. So moving on, I hope it is clear. Is it clear?
Yes, clear, madam.
Okay, very good. So now if it is clear, the CAN transceiver work is done. So what do we have next? What do we have next?
CAN controller.
Okay, correct. CAN transceiver is done. CAN control we have and microcontroller.
Controller
So
is
for these things, so we have a stage, right? One by one, we have a stage. So I hope everyone does the engineering. So I hope everyone knows the OSI model. Anybody is there someone who doesn't know the OSI model? Whatever you do on this field, either software, it could be hardware, it could be software, everything will be having its layers. Nothing but in general it's like stages. One by one you have to take it, otherwise you will not be having the control over anything. Correct, right?
1 minute, madam. I think in the batch there are some degree background guys are also present. So can you please elaborate this one? Yes, always.
Okay, so that is not part of this course. So this is a
Okay.
homework for you guys. You have to say like you have to come up with the what is exactly OSI model is, because whoever is studied the BE or BTech whatever, so they should be knowing what is OSI model is and what are the layers are available and what exactly the layer is for. Okay, so it's a homework. You guys have to explain to me in the next class. Okay, so then I'll come back to this later. Okay, let me consider CAN controller now. So why exactly why do you think we have the CAN controller? And first of all, why do you guys think we have only CAN transceiver, CAN controller, microcontroller as a ECU and it has been considered as a node? Why not others? Why not other, other chip or any other IC? So when I say CAN transceiver is one of the chip, you guys are aware, right? It's nothing but it's a chip with the number of pins. When I say CAN controller, again it's a chip. It's with number of pins and microcontroller. And embedding all these three, it's become an ECU or a node. So why exactly you think only these three has been considered as a ECU or node? Why not other ICs or why not others?
Sorry, ma'am. Could you please tell me the what is the node?
What is?
Node. Node meaning.
Okay. Are you joined
I'm
now
not.
or?
Yes, I am joining now. I'm a degree background. I'm not a
Mhm.
regular student. So could you please tell me the what is node?
I have been explaining if you remember an ECU or a node or a system. When I say these three, do you know what is ECU?
Yes.
Yeah,
That
nothing
one.
but the same. Node is also same. All three are same.
Okay.
Okay, just a name difference. Okay. So my question is why we have only these three? Why not, I can simply go ahead and add another one and I can use it for my project. Why can't I do it? Because it is a standard, right? So what is the standard name for CAN protocol? Anybody aware? What are the standards we have in our daily uses? Like just assume if you are buying a product, milk product, do you simply buy or
Here in this can, it is speed, like
uh-huh.
efficiency, all that, cost
Okay.
effective.
Mm-hmm.
All these are standards.
Okay. No, I didn't
ISO
mean that standard.
9001.
Very good. Yes.
It is a basic.
Uh-huh. So why do you think we have
Uh,
that standard?
they are following some set of rules for efficient working.
Very good. So now you have understood it is a standard. CAN protocol is a complete standard where it has been mentioned what to use, where to use, how to use, what not to use. So everyone has to must adhere to that rules and regulations which has been mentioned on the standard. Understood? So
Yes.
that's why we use only these three as a part of ECU or a node. Okay, it's a standard and it is telling that you have to use in this way. That's the reason we are using in that way. Okay, so now as per the standard, we have been telling that set of rules and regulations. So what exactly that set of rules and regulations meaning? Rules and regulations meaning when we say CAN protocol, nothing but it is a communication purpose, nothing but it has to send the data and it has to receive the data. So that rules and regulations like the data, how the data should be, how the data should be, and what is that limitations of for that data, how exactly the data should be, nothing but a format, how exactly it should be, and what should it can contain. These are all nothing but a rules and regulations which has been provided by the standard. So whenever it is communicating something, the data, there is a standard how the data format should be and what it should be, like every bit by bit and every like if we are talking about the data format, what is the first bit should be, what is the second bit should be, what is the third bit should be. So it's a standard. So now we are going to discuss how according to the standard how exactly the data frame structure is present. Okay, so any questions till now? And as a homework, please write it down. You guys have to answer me in the next class about the OSI model. And if possible, try to understand in the stages what we have seen as a node or an ECU, which stage comes in which layer and why. Clear?
I have one doubt, ma'am.
Yes, please.
In the ECU, there are three modules is there, like CAN transceiver, CAN controller, and microcontroller.
Mm-hmm.
I think we are sending some data. If
Mm-hmm.
it is receiving now, it is
Mm-hmm.
transceiver. If it is
Mm-hmm.
sending now,
Mm-hmm.
what we call it as receiver
Oh my
is
God.
present or not?
No, no, no. It's not that. See, when I say CAN transceiver, let me just, I'll just show you one CAN transceiver, how it looks like, so that, you can imagine the name. I forgot the CAN transfer which I worked on. Name of that. Okay. See, it looks like
Intel.
this. Okay, and like you don't go for the manufacturing as of now. So if you are using this as a the name of this chip is a CAN transceiver. So because every pin has been configured to do some, take some input and provide some output. Okay, so now tell me, according to your question, you are saying we have a CAN transceiver in the this one. So its job is to
Yes,
convert and take the input and provide the output onto the bus. Take the input from the bus, give the
yes. It,
output to
it,
the bus.
it can operate to both sending and receiving also.
That's what we have discussed, right? It converts the
Yes, yes,
voltage to the binary and binary to the voltage.
yes, yes.
Okay, so now your question is clear. I mean, I
Right,
hope it's
clear.
answered. Okay,
Yes, yes.
great.
Thank
Okay, no problem. So moving on. So I hope homework is clear, and I want everyone to answer. So now just now we have understood it is a standard. It has a set of rules and regulations how the communication should be. Nothing but I cannot simply simply send whatever I want as an electronic device. So how exactly the standard says that communication should happen in this way, nothing but then only other ECU can understand what you are trying to convey. So what is that? As a developers, you guys are going to develop all these things as per the standard. So as per the communication, we know what is exactly the communicating between the ECU to ECU. It's a data. Correct, right? Data means what? It's an information. Correct, right? If the radar or the camera or the sensor giving the data to the ECU, what does it mean? It's an information. Correct, right? There is someone near to your car in between of within 100 meters of your car, and some object is present behind your car within 50 meters or 30 meters or 1 meter. What does it mean? It's a critical information. Correct, right? If it is not providing and you are applying the reverse gear, give a reverse gear, what happens? Guys,
you.
hello,
You're
am
gonna
I
dash
audible?
the button, the person.
Yes. So that is the reason we should get the proper information at a proper time. So this is nothing but a information. How exactly information an ECU is gonna get from the another ECU? Nothing but if all three cameras are handled by the one of the ECU, so this ECU is gonna provide you now with the data. So that data should be understandable by the one of the another ECU. So to understand this data, nothing but an information, it should be in one of the format. So which has been standardized by the government. So now let's see what is the standard is. Nothing but standard frame structure is. This is how it looks like. The standard structure. So now don't worry about the standard and extended. We will come back to that. So this is how the communicate the data structure looks like. Nothing but an information structure looks like. So as a developer, anyway, you are not going to be a CAN developer because it has been developed very long back. So you guys will be working on the application layer. Okay, but anyway, if you are seeing CAN messages, you should be able to understand what does it exactly means. That is why we are learning all these things. Correct, right?
Yes.
Okay, so now let's see start of the frame. The frame structure of a can start with the start of the frame, and then continue with the arbitration field, and then continue with the control field, and then the data field, CRC field, acknowledgement field, end of the frame, and intermission. Please write it down. These are the fields we do have in the data format, nothing but a data structure. It's a data format structure. We will come back what is data frame means, what is standard and extended means. First, it is a standard structure for the data which has been receiving and which has been transmitting. Clear? So is it clear?
Yes, ma'am.
Okay. So now, before entering into now you just understood the what is the standard frame structure. So now assume how your ECU, all ECU in the car will be awake. What is the, like, simply do you think it will be awake all the time, or how is it? There should be, like, what is the request meaning? Like, do you do anything if your mind is not telling you to do? I mean, there is a internal request, is it? I mean to say, let me give the practical example now. So, do you think every ECU? So we have just seen there will be a 200 ECUs in the car, in the autonomous car, which is a L5 autonomous car. If do you think all the 200 ECUs will be always awake or always doing its work?
No,
It
I think
depends
it is
upon
not.
that. Depends. It
Depends
depends
upon.
on that the action it has to do.
Yes. So what is that, like, when exactly it start, taking care, doing its work? So as you said, it is right. It based on its action. So assume it's an engine ECU. So its action is to,
Run all the time.
okay, when it will
Like
start.
when
So basically, what is the, so it will simply start.
ignition.
Very good. So
While
when that ignition, like, so it's called a request. So this VCU will be awake when there is a request. Here the request is when you turn on your car, the action, based on the action, assume there will be a 50 ECUs inside the car, so all will be awake. Okay, who are active safety ECUs, I can say. So now let's say what is that request, we have just seen it. It is the ignition, or the you are turning on your car. Correct, right? That request is called a remote frame. Okay, so now remote frame. Okay, so now engine ECU start doing its job, and nothing but it's working, nothing but it's keep on sending the data to the all other ECUs in the bus. Correct, right? Nothing but it is working, nothing but what? It should be keep on, sending the status of the engine and whatever the I can say, like, many more it's there, but anyway, I didn't work on engine. So for example of status of the engine, it has to keep on sending to the whatever the ECUs is connected to the bus. That is the output. That nothing but that is how it takes the actions. That is how it takes the input. Correct, right? So when it will be awake based on the remote frame. If there is a request, it will start keep on giving the output, nothing but a response. What does it mean? That response is called a data frame. Clear? What is remote frame and what is data frame? Best example I will give if you're not clear still. So assume there is even airbag ECU. So when the airbag ECU will be awake?
when the incident is triggered, then airbag will be coming into the picture.
Yes. When there is an accident, then only airbag ECU will be taken. It takes its work. This accident, what is that? It's a remote frame. That's how it will get to know that I have to be active because of this request. Okay, so the airbag is taking the action now. So what does it mean? Nothing but it is sending data that I'm taking the action. It's also one of the data which will be sending on the bus and it will blow the airbag. That's an action. What is that means? Nothing but it will send airbag is blue. Like how other ECUs get to know that airbag is blasted. So ECU has to send that, okay, airbag is blasted now. It's done. So all other ECUs will understand. So when there is an accident, the engine has to stop by itself. And like how it will get to know? It has to apply the brake. Because of the request is airbag, sorry, accident occurs, which will be identified by the one of the sensor. Okay, so that is a request, and whatever the action is taking after that, it's like it's allow the response based on that request. It is taking care. Like those are all the actions which are taking care based on the request. That those are all the responses are called data frame, and the request is called remote or request frame. These are the mainly two frames which are present in the CAN frame, and we are going to discuss many more. What are the different types of frames? So as of now, the remote frame and data frame. So is it clear? So now the standard what we were discussing and the structure what we have discussed, I mean what we have just seen with the start of the frame, arbitration field, control field, data field, CRC field, acknowledgement field, end of the frame, intermission. These are all the complete, this is the complete one of the frame structure for the data frame. And there is a structure for the remote frame also, which will come back to that. So now understood? Yes or no?
Yes, ma'am.
Okay. So now let's start with the start of the frame. So the start of the frame is nothing but a start point that you are starting from this point, which will be always dominant. Okay. What is dominant meaning?
It
I
is
mean, in
0.
the binary, it is 0.
It is 0.
So yes, recessive, it's 1.
1.
So now I just need your, general common sense. The meaning of dominant is what? I'm not asking in the binary. I'm just asking in a, like, in your general use, you will say he is dominating me or she is dominating me. He was
Control.
dominating him. Yes. So recessive meaning, control, fine. What does it mean by domination or dominant?
More powerful. Powerful.
Uh-huh. Yes, it's a
It has a
powerful.
bigger value.
Controlling.
It's a powerful, correct, right? So assume
Yes.
there is a 0 and there is a 1 also, which is nothing but dominant and it is recessive. So whom do you think is powerful here?
0.
Very good. So assume 0 and 1 transmitted at the same time. So now who wins the fight?
0.
Very
0.
good. 0. Because it is a
Dominant.
dominant. So when there is a dominant, nothing but when I say the start of the frame itself is started with the start of the frame field, which will be always dominant. Okay. So when there is a dominant bit on the bus will be awake. Okay. It's from the any of the ECU, but any one ECU has to send the dominant bit to awake the bus. Okay. So once after the start of the frame, assumes like now we have just seen what is start of the frame and we know that it is always dominant. So the next is arbitration field. So when it comes to the arbitration field, it has 11-bit identifier, nothing but whenever I say the 11-bit identifier, the size of this particular arbitration field contains 11-bit plus 1 bit, which is RTR. Okay, let me just go here. So we are discussing now arbitration. In the arbitration, we have 11-bit identifier. Nothing but identifier you leave now. Just carefully listen. When I say the 11-bit 11 bits, nothing but how the memory allocation will be. So like somewhere it starts from the starting address and end with the one of the address. Correct, right? So 11-bit means, like, assume it is in a bit structure, not in a byte structure. 11-bit means you are going to have 1 bit, 2 bit, 3 bit, 4, 5, 6 up to 11. So this particular portion is fixed for the identifier. So what is identifier now? Okay, so just one example I will give for the better understanding. So we have been seeing, like, discussing about the cameras, radars and sensors. So now let's say one car, okay, it's having 4 cameras. One is on front, one is on back, another one is on side maybe, or whatever. Okay,
Side
so
view.
assume there, yeah, side. So 3 cameras are available now. So do you need 3 ECUs to handle these 3 cameras?
No.
Yes. So one ECU will be getting the input from all these 3 cameras. So now let's say how exactly you will get to know which data belongs to which camera. So now all these 3 cameras are giving the input to the ECU. So ECU will take up and it has to provide the output. Nothing but it has to send on the bus to get to know for every ECU which are connected to the ECU. Sorry, bus. So now how does ECU gets to know this information is from the front camera and this information is from the back camera or another is from the side camera? How exactly it gets to know?
With the identifiers.
Very good. So to identify which signal is, like, which frame is this, to identify that we have the identifier. So like you will be giving a number. If it is a 142, it is a front camera. If it is a 143, it is a back camera. If it is 145, some side camera. So that's how it classifies on the ECU whenever it is providing the output. So it says whenever you are getting the data from the ECU with the 142 identifier, you will understand it is a front camera data. Nothing but like which object is present near to your car within your 2 meter or 1 meter distance. Based on that, like, the data will be present with the identifier of 142. Similarly, 143 with the back camera, which will be same identifier, same data will be provided from the one ECU, but different information. Getting? Is it clear?
Yeah.
Okay. So now come back to the 11-bit. So 11-bit identifier, nothing but, as we know, only 11-bit is fixed for the identifier. So that is the reason I have written it is a 142 or 143. Okay. So yeah, so as of now it is okay, fine. Whenever I'll come back to the extended, I will say what is the use of extended or standard, anything on that. We will later discuss more about this. But anyway, so as of now you have understood what is identifier, right? And why exactly it is called 11-bit? Because it is only like 142 means what? How much of memory would be required to store 142? If you are writing, instead of 142, if you are writing 1550432 do you think if you provide this data in the, as a developer, if you are providing this data inside the 11-bit identifier, does it approve or does it accept?
Oh, it is.
Huh?
Yeah.
Sorry,
But no, no.
it won't accept, right? It will be overflow. Or first of all, it won't even accept completely. It will be overflow. So that is the reason we have to provide the number of IDs which can be providable in the 11-bit identifier. So how do you decide it then? How do you decide it? 2 to the power of 11. So how many identifiers do you think you can use it in one of the, in this particular, like, as we know there are multiple inputs, right? Here only we have taken one example of 3 cameras for one ECU. Similarly, like, the one ECU handles many more stuffs. So when it is providing the output, how many identifiers it can use? Nothing but how many things it can handle, in another words.
2 to the power 11.
Yes. What is 2 to the power of 11? What's the 2 to the power of 11?
2048.
Mm-hmm. These many identifiers you can create. Okay, now then we will come back to the 29 or extended identifier anyway. So now identifier is clear, right? We will come back to the prioritization part later. So now 11-bit identifier is to store the identifier with the 11-bit. Clear? Is it clear?
Clear.
Okay. So RTR, as you can see in the arbitration field, it has the size of 11-bit 11 plus 1. RTR has 1 bit of size. So totally arbitration field has 12 bits. Okay. So what exactly are RTR meaning? Something is wrong with this. Give me a minute, guys. Okay. So RTR is something like just now we have discussed, right? Remote transmission data. What does it mean? It's a request, right? Remote transmission data. I just explained what is remote data and remote frame and data frame. Remote or request frame. Remember?
Yes.
Yes. So that port, if whether it is a request frame or the data frame, that's what it will be identified by the RTR bit. It's the size of RTR bit is only 1 bit. If it is 0, nothing but if it is a dominant, it is a data frame. If it is a recessive, it is a remote frame. Nothing but request frame. So why it is always dominant in the data frame? Because always the response will be given the prioritization over the request frame. Assume first of all ECU will be responding or it starts action based on the one of the request. So one request came and you are taking your actions everything and do you assume there is another request. So the first preference will be given to the data frame because to complete the first job and then it will accept the next job with the next request. That is the reason in the data frame the RTR bit will be always dominant. Clear?
Clear.
Next is IDE, nothing but identifier extension. To explain this, I have to explain one more concept, which is just now we have discussed 11-bit and we do have a two types of data frame structure. One is 11-bit, another one is 29-bit. So now just now we have seen like how the 11-bit identifier looks like. Why do you think we have two types of data frame structures? And what is the use of having 29-bit structure? Just now we have seen and you guys know the answer also. I just want to, guys to think and answer.
If we are sending more than 8 bits, more than 11 bits data, we need to take 29-bit data, right?
No, you are not sending. That is an identifier, right? You are not sending anything. You are sending the data with that identifier to identify the input. Whether it is a first camera, front camera or back camera or whatever it is. It's an identifier. It's not the data. Correct, right? 142 we have seen, 143 we have seen. Remember, it's the front camera information and it provides the back camera information. After the identifier, whatever is comes is the data. We have not gone to data itself still now. We are still in the identifier. So why do you think 29-bit is important or required? Okay, so let's not waste the time. So as we know, 2 to the power of 11 was? Come on, guys.
2048.
2048. So how many identifiers you can generate?
20848 identifiers we have.
Nothing but you can generate with 2 to the power of 11 of identifiers. Correct, right?
Right.
So if you are using 29 bit, what is the 2 to the power of 29? Yes, do the calculation. I'm not so good at calculating this much of power, of course. It can be calculated by calculator.
53 crores, 68 lakhs, 70,912.
Okay, blah, blah, blah. Fine. Nothing but the concept here is the value of this 2 to the power of 9 is more than this. Agree?
Yes.
Yes. What does it meaning? Meaning one ECU can, nothing but ECU can send only the 2048 in the 11-bit. If you are configuring that ECU as a 11-bit identifier, you can use only 2048 identifiers. Nothing but ECU can provide 2048 frames. Okay. So if you use 29-bit identifier, you can configure 3 crores whatever some date, number more than this. Nothing but one ECU can provide 3 crores of frames, which is actually required in the autonomous car. Otherwise, you will have to use the multiple ECUs. So if you are using 29-bit identifier, you don't have to use multiple ECUs, because by using one ECU, you can handle multiple things here. Getting?
Yeah.
Okay, that is the purpose of 11-bit and 29-bit identifier. So let's go back to the IDE. IDE bit is having a size of 1 bit. The full name of ID is a identifier extension with the 1 bit of size. So the this bit IDE bit will be always dominant in the 11-bit identifier and also called standard data. Okay, nothing but data frame format, which also called 11-bit identifier data format. Okay, whenever I say 11-bit identifier data format or with the name called standard data format, both are same. Okay, so in the standard or 11-bit identifier frame format, IDE will be always dominant. Okay, so note down the whatever I'm explaining now, because the difference in the extended data frame format, you guys have to tell me why it is, what is the default values and everything, because extended data frame format, it's same. It's not going to take much time when you know about the standard or 11-bit identifier frame format. So IDE will be always dominant in the 11-bit identifier. Next, moving on to the DLC. What is DLC? Anybody aware what is DLC? And the size of DLC is 4 bits. So what is DLC?
Data length code.
What does it mean? Data length code, as the name suggests.
How many bits we have to transfer in the data frame?
In the data frame, correct. But one correction, in the data field, not in the complete data frame. Your answer is right, where DLC is the data length code. It is going to identify, we have to provide how many bytes of data we want to transmit.
4 bits.
Okay. The size of DLC is 4 bits. If it is a 4 bits, okay. Now tell me if okay, I'll come back to this whenever I go for the data field. Okay. So DLC, whatever you guys know is right. DLC is a data length code where it provides how many bytes of data you want to transmit. Okay. That is the that finishes the control field. So let's go to the data field. Then I'll come back to the DLC. So in the data field, we can send 64 bits of data, nothing but 8 bytes of data in a single frame. Okay, let me write it down. So when I say single frame, what does it mean? Anybody aware? Single frame, multi-frame. Anyway, multi-frame is not applicable for CAN. So single frame, nothing but. Okay. So when it comes to the data field, in the data field, we can send only 8 bytes of data. So nothing but we can send only 8 bytes of data in a single frame. So what exactly single frame is? This one. Start of the frame, arbitration field, control field, data field, CRC field, acknowledgement field, end of the frame and intermission frame. Anyway, you cannot see all these things because You will get to know once you explain me the OSI model. Why? Okay. So what you can see in the application layer, you can see only the data field. So in the and the identifier, that's it what you can see. And I can show you one of the example how it looks like. Mm, Okay, I'm not finding it. Maybe in the 2 minutes. Okay, it's open. See, this is the identifier. And there should be a name for this, right? Otherwise you don't understand this. The name will be keep on changing. You don't have to worry. It depends on the project to project. So this is the identifier. And what is the DLC for this?
16-bit.
Yes.
16 bytes.
So nothing but what is it? It's a CAN FD. That is the reason you are seeing 16 byte. So in the CAN, we can send only 8 bytes of data. Nothing but what? In the data field, the data field contains the actual data. Okay. So whatever you are sending, the data frame, arbitralization field, control field, these are all not actual data. Okay. So why is the identifier? Identifier is used to identify the data or information from which input source. Okay. And RTR bit and IDE, these are all the comes in the configuration. Okay. And the DLC is, as you guys already know, it's a data length code which is used to identify how many bytes of data you are going to send. So in where? In the data field. Data field is the field which sends the actual data. Nothing but assume there is a object near to your car within the 2 meters or a meter. Okay, it's like almost it's gonna hit or in front of your car. Okay, so that time how exactly it is sending the data? So of course it cannot say simply, oh man, you are having one of the object in front of your car, correct, right? And the brake will be saying, yeah, I can see that and I'll apply the brake. No. So it, like, how the communication is happening? So one ECU, like nothing but a sensor, will be transmitting the data to the sensor control unit, and from there it comes to the brake ECU, and where the brake ECU takes the action. Correct, right? So once the sensor is identifying, it will send to the sensor controller unit. So how it is sending? Through this messages. So how it understand, how the ECU understand it is from the front sensor, because it has one of the ID with the one of the 11-bit identifier, which is 112. So with the 112 it understood it is from the this sensor, nothing but with the front sensor something. And then so this sensor is sending some data with the 8 bytes. And what is the data? X1, X2, X3, X4. This data X1, X4, X1, X2 stands for there is an object. If it is a 0, nothing but, so if it is a 0, 0, 0, 0, and if it is a 0, 1, it means an information. Nothing but 0, 0 means there is no object in front of, in between of 1 meter, I can say. If it is 0, 1, there is an object in the after the 2 meters, like this is an information. This is what actual data which is present on the data field. And how many bytes of data you are going to send on this data field will be identified in the DLC, which is data length code. And in the CAN protocol it is fixed. Nothing but standard says that you can send only 8 bytes of data in the single frame. Nothing but in the data field only you can send only 8 bytes of data. So clear? Is it clear?
Yeah, clear.
Okay, so next
Yes,
is
ma'am.
CRC field and acknowledgement field. I'll just quickly finish it off this structure. Okay, CRC field. So let's say, so how are you? Okay, let me just give one of the example. Everybody aware of the hacking, right? So assume our ECU, it's taking information from the someone else. third party, like someone else, which is not even this, our ECU is not even authorized to take the information from the any other ECU, but still it's taking an information from the some other ECU which is not supposed to take. Our ECU is has to consider the input from the authorized ECU, one of the ECU which is connected to the node, which is connected to the bus network. Okay, so how are we confirming that our ECU has received the input from the proper ECU and whatever has been received is the proper data? That is what is error check. Just now in the one of the feature we have seen error free communication, right? So that's what is it means. So whenever someone is sending the data, we have seen 112, which is one of the sensor which is sending some 8 bytes of data with the data x1, x2, x3, x4 up to x7. So if it is sending this data, how our ECU, like one of the ECU has sent this information to one of the another ECU on the bus. I'll write down like this so that it's easy for you to understand. ECU A, ECU B. ECU1 sent this information on the bus and it is accepted by the ECU B. How it is accepting? We will see that later. But assume now ECU1 is sending the data to the ECU B and ECU B accepted that information completely and it started nothing but processing. So how exactly ECU B confirms that this is the proper data which has been received by the ECU A? There should be a check, right? There should be some confirmation for the ECU B before accepting or process the data before completely accepts the input from any other ECUs. Correct, right? So just general example, you guys will not be here or listening to me if I am not working at automotive domain or if I would have not worked for 4.3, 4.5 years on the automotive testing domain. Is it correct, right? Do you really listen to me if I say I never worked on CAN protocol? Hello?
No.
Correct, right? So how, like, what is that confirmation for you? That's I have worked at I have worked on this automotive domain for 4.5 years. That is the confirmation. That is the reason you are trusting me. Correct, right? Similarly, in this ECU also, how the ECU B confirms that this is the proper input from the ECU A. So that's how, like, there is a check, there is a confirmation from the ECU B side to understand it is a proper data from the ECU A. That is what is called a CRC check. It is gonna check something on the message. What is that? We will see it. Okay, we will see it like once after finishing of the basic of this, we will see it. So now the basic information of CRC check is understood, right?
Yeah.
Okay, so the next is acknowledgement field. So whatever I'm explaining, if you are understanding and if you are answering me or replying me, then only I will understand. You guys are able to understand. Otherwise, what I will think, whatever I'm teaching, it's waste because I'm not getting any response from you guys. That's how I will get to know whether my information is delivered to you properly or not delivered to you properly. Correct, right?
Yeah.
Yeah. So similarly, here the same thing is for the acknowledgement field. Nothing but whenever I am explaining something, you are saying, okay, yeah, understood. This is how it is working. Nothing but you are giving me an acknowledgement that you are getting my point. So that's how I got to know that, okay, you are able to understand. Similarly, if this ECU is sending the data to the BECU, BCU has to acknowledge that I have received your data to the AECU. Otherwise, ECU-A will not understand whether anyone in the node has received my received my data or not. If someone is acknowledging, then only ECU-A understand, okay, someone received my data. Otherwise, nobody has received my data. That is what called acknowledge. That is what is done by the acknowledgement field. What happens if nobody is, acknowledging that? We will come back. That is an error. Okay. So, and in the CRC check also, if someone is not, when the confirmation is not done, ECU B has not got the confirmation from the ECU A. What happens? It's an error. It's a CRC error. If it is confirmed, that like how it is confirming to do all these operations only, we have some specific memory location specified, which is 15 bits for the CRC field, and acknowledgement field we have, which is a, I mean, I don't remember the complete size of this acknowledgement field. Yeah, I'll tell you tomorrow. I think it's 1 bit for acknowledgement slot and acknowledgement delimiter, and CRC delimiter is also 1 bit. I will come back to you what is delimiters, but as of now CRC field basic information is clear, and acknowledgement slot is for the acknowledgement purpose. What is that acknowledgement means? So ECU has to acknowledge that I have received data from the another, like if the ECU A is sending the data to the ECU B has to acknowledge that I have received. If it is not acknowledging, then it will become a acknowledgement error. So it's clear?
Yeah.
Yeah. So next is end of the frame, which is having a size of 7 bits and the default values are recessive, and also intermission space, which is having a default size of 3 bits, which are also a recessive. So intermission end of frame is like end of the frame. How we have the start of the frame? Like nothing but we have a 1 hour class now where we have started at particular time and we are going to end at particular time. Similarly, the starting point and the ending point of the frame, nothing but a data. So in the intermission frame is 3 bits, nothing but it's a delay. So in our case, we have a 1 day gap for the next class. Correct, right? But we cannot have the same here because there are too many communication, like too many messages needs to be transmitted from one ECU to another ECU. So it's a delay of 3 bits for the next message. So why it's that next message in the queue, we will see in the next class. How it is, why it has considered the first frame and why it has kept the message in the queue, that we will see in the next class. So any doubts so far?
Yeah, okay. In standard date format, okay. In real time, okay, we will use 11-bit identifier or 29-bit identifier.
Mm-hmm. In real time? Yeah, in for the like you cannot configure every ECU with the 11-bit at only 11-bit or only 29-bit based on the criticality again. Okay, so if you have one of the ECU which is providing, like you want that ECU to handle so many inputs and take the actions, that time you will use 29-bit identifier, because you can have the multiple output frames from that one particular ECU, which will be used in the in the, I can say, we have used in the airbag also, and we have used in the engine also, and we have used in the brake systems also. Like these are all critical ECUs when it comes to the car system.
Yeah, okay, fine.
Yeah. So any other doubts? Sorry.
No.
Okay, so in the next class, we will see the extended data frame format. It won't take much time, since if you are aware of standard frame format properly now, and we will see how the prioritization happens and how the ECU accepts the message from the another ECU. Okay.
Okay.
Okay, fine then. Thank you, everyone. Bye bye. So, Lokesh, do you have anything to say?
No, that's fine, Hamza.
Okay, fine. Okay, guys, thank you. Bye bye. Good night.
Thank you.
Thank you.
Thank you all. Bye bye.
Yeah, ma'am. Thank you.